Question 3, find the range of values of the constant k in the equation blah that has no real roots. So in this case, what I'd like to do is I'm going to draw a graph with this one. And I know the answer which they give you doesn't have a graph, but I think it's time we actually added a graph so you can see the relationship of this in terms of other values around it. So here's the equation first of all. So we've got an x squared plus kx plus 16 is equal to 0. And we're told it has no real roots, which means that the discriminant must be less than 0. All right, think about that. The discriminant's less than 0. So if we were going to plot this thing, we could plot the values of k along here and the values of the discriminant along here. And we know when the discriminant is less than 0, up here the discriminant values are going to be 1, 2, 3, 4, 5. Up here, down here, the discriminant values are going to be less than 0, -1, -2, -3, and so on. So let's see how this actually plays out with respect to this idea of a discriminant versus a k value. Because really, remember, this is not x and y. This is just all about that thing there. And we want to know the range of values for which this would be true if there were no real roots. That's what we're doing. All right, so let's go ahead and do that now. So first of all, let's find the a value here. Well, we know a is going to be 1, and b is going to be k, and c is going to be 16. We've got the discriminant, which is b squared minus 4ac, and we know this must be less than 0. So let's populate this with what we know. We've got a k squared minus 4 times 1 times c, which is 16, less than 0. And this works out really well. We've got a k squared. 4 times negative 16 is going to be minus 64 is less than 0. Well, I'm just going to subtract 64 from both sides. Oops, no, wait. I'm adding 64 to both sides because it's a negative. So I'm adding 64 to that side, adding 64 to that side. That becomes 0. So I've now got a k squared is less than 64. So I'm going to find the square root of both sides. And that's going to be plus or minus. Square root of a square becomes a k. So it becomes the square root of 64 is plus or minus 8. So there it is. I've got a k is less than plus or minus 8. So what does that mean in terms of this graph we had here? Well, the k values are either going to be plus 8 or minus 8. So let's redraw the graph. I didn't leave much room around this thing here. So here it is here. So I'm going to make it, I'll do it like this. So here's my 0. This is my discriminant. This is my k value along here. And this actually goes very, very, very deep, by the way. But because really, when you think about what you've got here, if I got k squared minus 64, I know we've got k is plus or minus 8, but really we're talking about if I've got k squared minus 64, that's the difference of two squares. That's k plus 8 and k minus 8. And that's the discriminant. That's what the discriminant is equal to. So if I was to plot this here, I would get a graph that looks like this. I would get a plus 8 here. I would get a minus 8 over here. And, well, 8 8s are 64, negative 64. So it's going to be down here. It's going to be, here somewhere, and it's going to be 64. So let's try and graph that. It's going to be something like this. It's going to go down. It's going to turn around like this. It's going to come back up here like this, through here, and so on. But the question, of course, is where are the values of k less than 0? Where are the values of this less than 0? Well, less than 0, k is greater than 0 up here and less than 0 down here. So it must be the values not above here, because the values above here are these values over here and these values here, because I mean, this value here is over here, this value here is over here. But this value here is inside here. This value here, for example, is over here. This value over here is inside here, and so on. This value over here is this value here. So we're looking at the values inside here, in between these two. So it must be, this is the part where the discriminant is less than 0. So the discriminant must fall between here and here, not outside here and here, but in between these two. So you've got to be a little bit careful. And there's a big tendency here because this is a kind of a parabolic type expression, you wouldn't want to say either k is 8 or k is negative 8. That would be true for what we call the critical values. That thing there is what we call a critical value. Yeah? And this over here is a critical value. That's the points which define where this heads off in either direction. But they're not the answer. The answer is the bits in between those two. If I was drawing this on a number line, I would draw it like this. I would say I've got a 0 in the middle, and I've got a negative 8 here, and I've got a positive 8 over here. And it's going to go not touching here, not touching here, but everything in between. So I would be able to write this as k is going to be less than 8, but greater than negative 8. And I would also be able to say that k was an element of real numbers. And that there is my answer. That's what they're looking for, by the way. I don't think you need to put this here, but nonetheless, that's what they're looking for. They're looking for between here and here. So there is our answer. Negative 8 is less than k, which is less than 8. K is greater than negative 8. K is less than 8. And that there would be the answer. And that's why, because the discriminant is positive here, negative here, and all of these values here result in negative k values, result in k values in between these two values here. Whereas values up here result in values here, which end up out here, which are outside the values we have. So that's how the answer works, and I hope that makes sense.